General Physics 1, Quarter 2, Module 4, Mechanical Waves and Sound. Lesson 1, Sound Waves. What is sound waves? Sound waves are a type of energy that's released when an object vibrates. Those acoustic waves travel from their source through a medium, like air or water, and when they come into contact with our eardrums, our brains translate the pressure waves into words or music or signals we can understand. What is the importance of sound waves? The vibrations from sound waves cause our ears to send signals to our brains to create sound. The speed of sound waves will determine the sound's pitch, or how high or low something sounds. Sound waves are important because they allow us to hear important messages and emergency signals to protect ourselves. Production of sound waves. Vibration. Vibration means quickly moving back and forth about a point of equilibrium. If it vibrates in a regular way, it may produce a musical note because it can make the air vibrate. This vibration will send sound waves to the ear and to the brain. Compression. Compression is used in music to reduce the dynamic range of signals with loud and quiet elements so that both can be heard clearly. Think of the difference between a soft sound, like a whispered vocal, and the aggressive crack of a snare. Rarefaction. Rarefaction, in the physics of sound, segment of one cycle of a longitudinal wave during its travel or motion. The other segment being compression. This is rarefaction. A succession of rarefactions and compressions makes up that longitudinal wave motion that emanates from an acoustic source. Sound waves. Its characteristics. Audible sound waves. The human ear can easily detect or sense the frequencies which lie between 20 Hz and 20 kHz. Hence, the sound waves with a frequency ranging from 20 Hz to 20 kHz is known as audible sounds. Infrasonic wave. Infrasonics, vibrational or stress waves in elastic media, having a frequency below those of sound waves that can be detected by the human ear, below 20 Hz. The range of frequencies extends down to geologic vibrations that complete one cycle in 100 seconds or longer. Ultrasonic waves. Ultrasonic wave is defined as inaudible sound with high frequency for human, the frequency of which generally exceed 20 kHz. These days, sound wave which is not intended to be heard is also called ultrasonic wave. Frequency of a wave. In physics, the term frequency refers to the number of waves that pass a fixed point in unit time. It also describes the number of cycles or vibrations undergone during one unit of time by a body in periodic motion. Pitch. The sensation of frequency is commonly referred to as the pitch of the sound. A high-pitched sound corresponds to a high-frequency sound wave, and a low-pitched sound corresponds to a low-frequency sound wave. Wave fronts. Wavefront, imaginary surface representing corresponding points of a wave that vibrate in unison. Wavefronts for longitudinal and transverse waves may be surfaces of any configuration depending on the source, the medium, and the obstructions encountered. Plane waves. In physics, a plane wave is a special case of wave or field, a physical quantity whose value at any moment is constant over any plane that is perpendicular to a fixed direction in space. For any position in space and any time, the value of such a field can be written as the Doppler effect. The Doppler effect, or Doppler shift, describes the changes in frequency of any kind of sound or light wave produced by a moving source with respect to an observer. Waves emitted by an object traveling toward an observer get compressed, prompting a higher frequency as the source approaches the observer. Lesson 2: Sound Intensity and Resonance. What is sound intensity and resonance? Sound intensity, amount of energy flowing per unit time through a unit area that is perpendicular to the direction in which the sound waves are traveling. Unlike loudness, sound intensity is objective and can be measured by auditory equipment independent of an observer's hearing. The inverse square law. The inverse square law for electromagnetic radiation describes that measured light intensity is inversely proportional to the distance squared from the source of radiation. Photons are distributed with respect to area, a squared unit. The reasoning for the inverse square law is geometric in nature. The inverse square law for electromagnetic radiation describes that measured light intensity is inversely proportional to the distance squared from the source of radiation. The threshold of hearing. The hearing threshold is a sound level below which a person's ear is unable to detect any sound. For adults, 0 dB is the reference level. It means that the hearing sensitivity decreases and that it becomes harder for the listener to detect soft sounds. Threshold shifts can be temporary or permanent. The threshold of pain. The threshold of pain, or pain threshold, is the point along a curve of increasing perception of a stimulus at which pain begins to be felt. It is an entirely subjective phenomenon. A distinction must be maintained between the stimulus and the person's or animal's resulting pain perception. Relative intensity. The relative intensity noise, RIN, is the ratio of the intensity fluctuation to the time averaged intensity. Decibel. Decibel, or dB, unit for expressing the ratio between two physical quantities, usually amounts of acoustic or electric power, or for measuring the relative loudness of sounds. 1 decibel equals 10 times the common logarithm of the power ratio. Forced vibrations and resonance. An object, when forced to vibrate at a certain frequency by an input periodic force, is called forced vibration. Resonance occurs if the object is forced to vibrate at its natural frequency. Forced vibrations. Forced vibrations is a type of vibration in which a force is repeatedly applied to a mechanical system. Forced vibration is when an alternating force or motion is applied to a mechanical system. For example, when a washing machine shakes due to an imbalance